Class, and we have been discussing on some of the concepts based on S parameters. We have discussed on the properties of S parameters and what do you mean by unitary property and symmetrical with respect to the S parameters. And we have compared S parameters with Z and Y parameters as well. And these were the things we discussed in the previous class. And as I have told you, that S parameters properties are very important for exam point of view as well. So you need to study those things without missing that topic. Okay. And if you talk about that problem as well, we have seen problem, or it can be also partly like a derivation. So you can see that where you have written the S parameters in terms of Z parameters. So you got matrix S is equal to combination of Z. So where you have seen those things. So we have also seen that matrix S can be represented as, see here, we have taken in the question that Z1 and Z2. So the parameters are there in terms of Z1 and Z2. If you have defined it in Z0 and ZL, so you need to just follow those things as per that. That small changes you have to do it here. So if here you got Z2 minus Z1 divided by Z2 plus Z1 and 2Z1 divided by Z1 plus Z2, 2Z2 divided by Z1 plus Z2 and Z1 minus Z2 divided by Z1 plus Z2. This is what you got for matrix S. And further, when we proceed that, we can understand that these parameters can be utilized to find out the relationship between Z and Y, ABCD, and S parameters. So these things we have already discussed, and we got the comparison between the Z and ABCD parameters, and we have written what A is equivalent in terms of Z, and we took these equations and we got C is equal to 1 by Z21 and D is equal to Z22 divided by Z21. And further moving on with the A, you got Z11 divided by Z21 and B is equal to Z11 Z22 minus Z12 Z21 divided by Z21. This is what all of you might have completed till here. All of you have completed?
Yes, sir.
Yeah, so it's pretty clear for all of you that how these things are interrelated to each other, and then let us move further and check it out how this Y is going to have an impact. So admittance. So we have the equations for Y, and we can write the equations for Y as I1 is equal to I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. If you want to see the matrix form of that equation, you can just refer some 4 to 5 pages behind the first starting part of the module 2. We have discussed all these things. So we have almost uh, wrote the equations for this at that point of time as well. So we got and these equations are quite familiar with you. You have been using it quite a lot. So what we are going to see here is I am just going to take the equation. I'm going to convert this equation and I'm going to just write it in this form. So what we are going to do is I'm going to take V1 is equal to, because you know that if you compare this equation with ABCD, so you need V1 and you need in terms of V1 and I1. So I am just modifying that equation so that I can compare and get the values for A and B as well as C and D. So when I did that, I got V1 is equal to minus Y22 divided by Y21 and V2 plus Y1 by Y21 I2. So we can compare it and check with the ABCD parameters. So you can see that you need to compare this equation with this equation. So you need to compare this equation with this equation. So what you can see is From this you can see V1 is equal to A V2 minus B I2, and from there you can take it out A and you can take it out B. So this is what we are going to see further and simplify it. So let us see that when you compare those equations, so what you will get, A is equal to minus y22 divided by y21, and B is equal to minus 1 by y21. So you can just write down these things. When you do it, you will get it. You can see those things further. So after that, similarly, you have to find C and D as well. So let us see what is C and D for this in terms of Y parameters. So have you completed this? Just complete it. You will get A1, A and B in Y parameters, and we'll see what is the relationship of C and D in terms of Y parameters. If you have completed, let me move further.
Yes, sir.
Okay. So you got A and B, and similarly, when you go with the equation for V1, so when you go for the equation for V1 in I1, so you'll get I1 is equal to Y11 in square brackets minus Y22 by Y21 V2 minus plus 1 by Y21 I2 plus Y12 V2. So this is what you're going to get for I1. So from this, when you do the comparison of I1 with ABCD parameters, so I have just taken the common terms together, that is V2 together and I2 together. So when I compare, I have to compare with this equation, that is for ABCD you have the other equation, that is for I1. So you have C and D there. I1 is equal to CV2 minus di2. So let us see that how it is going to uh, get, and you have this I1 V2 and I2. So from this, by comparing, you will get C and D. So you will get C is equal to y12 minus y11 y22 divided by y21, and D is equal to minus y11 by y21. So this is what you're going to get, A, B, and C and D in terms of Z and Y. So this is what you can just understand from this. I think you have already studied these things in network also. You might have done in the same way the comparison between ABCD parameters with Z and Y parameters. The same thing, we just repeated it here. So we are going to see the equations for uh, so you just complete it till here, and we can also represent y in terms of a b c d as well. So y11 will be d by b, y22 will be minus a by b, y12 will be 1 by b, and y21 will be c plus ad by 2. So this is all once, usually they don't ask this, but once in one of the question paper they have just asked the comparison between all these parameters. So you can just prepare it, and you can just keep these equations ready so that it will be easy for you to simplify. Uh, if you have completed one more set of equations, we'll have where we relate the ABCD parameters with S parameters. So we need to find out S11, S12, S21, and S22. So we'll see that how these ABCD parameters are interrelated to S parameters. If you have completed this, shall I scroll down?
Yes, sir.
Okay. So these are some of the relations what you're going to get with respect to y parameters and z parameters when you compare it with the a and b, c and d parameters, abcd parameters. So similarly, we can write the S parameters as well in terms of ABCD parameters. So when the characteristic impedance of the input and output lines at the junction are same, then only you can use this equation. So you have to make sure that the characteristic impedance of input and output lines at the junctions are same. So once the input and output characteristic impedance of both input and output at the junction are same, then you can go ahead with writing this equation in terms of ABCD. So these are the four equations what you get for the parameters S11, S12, S21 and S22. So these equations you can just understand. So it's very easy to remember. If you see that all the equations will have the denominator the same, only the numerator is slightly varying. So we can see that all the denominators are same. So the first equation to talk about is for S11. So we'll be having S11 is equal to, yeah, a minus, this is the first equation, a minus b minus c plus d divided by a minus b plus c minus d. So all the denominator portion is same for all the four, and but the numerator you can see there is the variation in that. So S22 will be written as minus a minus b minus c and minus d, and the denominator is a minus b plus c minus d. And further, if you go with S12, you will be having minus 2 into AD plus BC divided by A minus B plus C minus D. So if you go with S21, it is 2 divided by the same denominator A minus B plus C minus D. So it is easy to remember as well. So you can just see that there is some certain pattern where you can see how you can remember these things further. So you can see that it is A minus B minus C and D. So here all it is negative. So S22 is easy to remember. And if you see that if you study the first equation, no, that you can just take minus 2, you need to remember both positive you put together AD plus both negative you put together BC. So it is very easy, and the last one is just 2 in the numerator. So it's not difficult for you to remember, and because we have written the straightforward equations here, and if they ask you the relationship between all these parameters, you need to go ahead with all these equations. So complete it till here. So once you complete it, we will just proceed further. So just let me know that once you complete all these equations. So we have written the equations of ABCD in relationship with Y. We have written in relationship with Z. We have also written with respect to S parameters. So it is interrelated to each other only when you can say that the characteristic impedance of the input and the output lines at the junction are same. Okay. So that is what you can understand from here. So you complete this. Once you complete, let me know that. Have you completed?
Yes, sir.
Okay, so these are the equations for you to understand, and we have seen all these equations. So this is all about the equations and its relationship with the S parameters. Now we have studied in detail all the parameters and its properties, its relationship with each other, symmetric nature, and all those things. Now we are not going to further study more about the S parameters. We are going to use this S parameters in the further classes. So you should know that if you are having a two-port network, you will be having a 2 cross 2 matrix, that is S11, S12, S21, and S22. If you have a three-port network, you will be having 3 cross 3 matrix, that is S11, S12, S13, S21, S22, S23, S31, S32, S33. And you have to understand that if it is symmetric, Sij is equal to Sji, and you have to use all these things in the next upcoming classes, and you have to solve some of the equations there. So I think all of you are clear with all these things till date. Any doubts are there? It's clear for everyone?
Yes, sir.
Okay, so we will proceed further. So all of you can just note down this as microwave next half of the module. That is the next half of the second module. That is microwave passive devices, where we will be studying coaxial connectors and adapters. Already we have discussed the coaxial connectors and adapters in the previous class. You can just make a note of coaxial connectors and adapters in detail. So where you have to draw the figures of that and understand those things. So it is you can just refer to the coaxial connectors and adapters in Annapurna Das, and it is available in page number 154. So that is we have already discussed that connectors like APC connector and all those things which I have discussed quite long back. So you can just use those things, and you can write some more explanation for that, and come out with a good answer for 3 marks or 4 marks. Okay, so 4 marks maximum, which can be asked on coaxial connectors and adapters. All of you should refer 154 page of Annapurna Das and draw those figures and practice the connectors. So we have already discussed the connectors in the previous class as well. So if you see that, I think here somewhere, yeah. So here we have seen APC connector, BNC connector, SMA connector, SMC connector, TNC and type N connector. So this is the same coaxial connectors what we discussed, but all these connectors you have to draw the figure and discuss in module 2. So you make a note of it and try to make a half a page answer for that, for coaxial connectors and adapters, how this connectors look like, and what are those. So what APC connector is. So it's, you can take it as a small assignment where you have to just prepare each connector with its diagram. Okay, try to do that. And if you have any doubts, you can discuss with me. Try to write APC connector, its diagram, and BNC, its diagram, then SMA, SMC, and TNC, and type N. So I want you to just open the book and see what all things are there, and try to do that. And if one of you complete the answer for that, you can feel free and post it in the M&A group, and so that others can also make a note of it. Okay, so I want you to do it probably by tomorrow or day after tomorrow morning. You can put it. So you can try that what all things are available, and have any one of you have taken the textbook? You could get the textbook. Okay, so it's it was possible last month because all the libraries it was open and all. Okay, fine. When you are able to go to institute, that time you can just take the textbook and go through it. Okay, so here all of you just write down the title, microwave passive devices, and now we are going to discuss about attenuators. Very important topic, attenuators. A definite question for examination, attenuators. See, we have 2.5 module for microwave and 2.5 module for antennas. It's very easy to get full out of full in microwave. Maybe you may miss 1 or 2 marks in antennas, but you should never miss 1 mark in microwave because it's always the questions will be predicted, and you will not get any unsolved problems or anything like that. Most of the cases you will be knowing that, or you might have seen those questions here or there. So, and all will be derivations and problems. So so don't miss the marks there. And now I will continue with attenuators. So all of you might have written microwave passive devices. Also you write coaxial connectors and adapters. You should refer that. Okay, I will talk with attenuators. So from the word attenuators means it has come from attenuate. Attenuate means either just stop something or uh, allow as per your requirements. So attenuators main role is to just see that what is required for the user, give that much only. If the user doesn't want that, just attenuate the things at that point of time. So or at that transmission line process. So when the signal, see, like when you are transmitting the signal in the real time applications, so you might have seen that most of the cases it is sometimes the amplitude goes very high and you don't need so much of signal at that receiver end, so you may have to attenuate the signal as well. So it is very important that some of the signals has to be removed or some of the signals has to be attenuated. So attenuators plays a major role in the transmission line, and it is very important for us to know that how best you utilize these devices as per your requirement. So in some of the applications, it may be very much important. So we'll be studying some of the types of attenuators and all those things for your reference. So attenuators are passive devices used to control the power level, as I have discussed with you. So the power can be varied. You want to completely close that transmission of the signal. Like somewhere you could have seen that if you see the flow of water, so you may have seen that stoppers will be there. Some places that you want to completely deviate the signal to some other point and you don't want any signal to pass through that. Same way, you can stop the entire flow of water as well. Similarly, the entire flow of the signal as well in the transmission line, or you can deviate the signal, or you can reduce the transmission strength or the power level and all those things. So that is the main requirement for attenuators, and attenuators are always the passive devices used to control the power level in microwave system by practically what their main thing is that they are going to absorb the transmitted signal wave. So they are going to absorb the transmitted signal wave. This is what it is going to happen. They will absorb the signal wave, and there are fixed and variable attenuators as well available. So some cases you may have to eliminate the entire flow of signal, so you may go with the fixed attenuator, but in some cases you may have to have a variation in attenuation, like now for 1 hour of time you need so much of power to be passed through that transmission line, and further after that you have to reduce the power level. So you should have the ability to vary the attenuation, and so we have two types of attenuators. One is called as fixed attenuator, another is called as variable attenuator. So what its main process is that it is going to absorb the transmitted signal wave when it is passed through the attenuator. So we are going to use a thin resistive film for this process. So resistive films are used for their design process. So we have seen all these things. So they are passive devices. They are used to absorb the power levels or to control the power level, and they basically absorb the transmitted signal wave. And we have two types of attenuators. One is called as fixed attenuator, and another is called as variable. And the resistive films are used for their design. And we also can see that a coaxial fixed attenuator uses a film that we are going to see now two types of attenuators. One is fixed attenuator, another is variable attenuator. You can just complete that introduction section. So I will be first talking with respect to fixed attenuator, then we'll be going ahead with the variable attenuators in the later sections. Okay. So, but you mark this attenuators as very important, an expected question for internals as well as for the university examination. So attenuator is very important. And I have not seen a question paper in university without being asked with variable attenuators and fixed attenuators. Most of the question papers, this is asked. So you have to prepare for it, and prepare for 6 marks, 7 marks, or maximum 8 marks. Okay, so we are going to see that this. So you can just write down these things. Then we'll move on with fixed attenuators, and we'll discuss upon fixed attenuators. So you can just let me know that once you complete it. All of you have to write from here. So if you have completed writing that, have you completed? Have you completed? Okay, you can complete it. So all these points you should keep in your mind, like they absorb the power level, like they are used for absorbing the transmitted signal wave. You have two types basically, fixed and variable, and thin resistive films are used for the design of the system. So all these are the points which you have to add on when you really write the answer for the attenuators. So if you have completed till the design of till the design point, have you completed? So just respond to me, or you are still writing it.
Wait.
Okay, I'll wait for some more time. So you can draw that figure as well. That figure we are going to explain further. That is a fixed attenuator. So you have to be very careful. You should put that edges very sharp when you are drawing it. So there are some significance for that. Once you complete it, just let me know that. Okay. So have you completed it? It's over.
Yes, sir.
Okay. So we'll proceed further. So we have been discussing on coaxial and fixed attenuators. Now we'll discuss on coaxial attenuators. So the fixed at you we know that there are two types of attenuators. One is called as fixed attenuator, another is called as variable attenuator. So now we are going to discuss on coaxial fixed attenuator. So that is what a coaxial fixed attenuator uses a film with losses on the center conductor and absorb some of the power. So what here you can see is you can see that this is the transmission line, and you can see this is where the signal has to flow. So the signal will flow like this, and when it should be sharp here. You can see that it is maintained very much sharp, and there is some reason behind that why it is kept so sharp. Okay, so what the main purpose of this is the resistive film, and which is placed in the transmission line, and the main purpose of this resistive film is to really absorb the signal and make sure that nothing is being received at this point. So that is what you are going to see. How it is going to do is the main thing is that you have a thin resistive film being placed at the center of the coaxial line, means this transmission line, and you can see that the fixed wavelength consists of thin dielectric strip coated with a resistive film and placed at the center of the waveguide parallel to the electric field. So what will happen is this resistive film, the induced current on the resistive film due to the incident wave result in power dissipation leading to the attenuation of the microwave energy. And so what you are going to see is when the wave falls on this resistive film, the power dissipation will take place, and the energy will be attenuated, and the dielectric strip is tapered. You call this process as tapering, where you are having a very sharp edge, and the dielectric strip is tapered at uh, both the ends, and the length is more than half of the wavelength. Why we are doing it is to reduce the reflection. So that is the main purpose, and it should be more than half of the wavelength. So that is what you can see. So the fixed wave, so in the fixed connection or fixed attenuator, it consists of a thin dielectric strip, and it is coated with resistive film, which is placed in the center of the waveguide and parallel to the electric field. So what it will be doing is it will absorb the all the power what is being at that film, and finally you are going to attenuate the entire signal, and that here you can see that there is a tapered edge at both the sides of the resistive film, and the main requirement of having that tapered edge at both the sides of the resistive film is to avoid the reflection. So you know that in transmission lines there will be reflection. So if you have that tapered edge at both the sides, and which should be more than the half of the wavelength, that is lambda by 2, so it should be more than that. If it is that case, then you will not have any reflections as well. So this is what you can understand about the fixed type of attenuator. So you can just see these things, and just note down these points. So we have understood about the fixed attenuator, and the main purpose of the fixed attenuator is it's not going to allow any of the signal to be passed to the other side of the transmission line. So it is going to absorb the entire signal, and you have tapering at both the edges to avoid the reflection. So that is the main purpose of using a fixed attenuator. So there will be many applications where you need a fixed attenuator, or you may need a variable attenuator and all those things. So in the lab, we'll be doing experiment with the help of we'll be doing one of the experiment, that is test bench, where you will be going and doing the experiment based on the uh, variable attenuator. You can see in the lab the variable attenuator, where if you see through the gap, you can see that the resistive film is going to be moved up and down as per the variations which we are going to create in the resistive film. So that is, we'll be seeing that in the lab most probably when another 1 month or so, if the college reopens, we will be having an opportunity to do that. So we will see all these things. So just write down these things now. And further you can draw the diagram for a variable attenuator. I'm going to show you the diagram for a variable attenuator to complete the things. See, you better note down in the class itself because all these points, once you write it, it will be convenient for you. And we have quite sufficient classes to complete. Almost we are completed 1.5 module of the syllabus. So 1.5 module, it's almost 30 to 33% of the syllabus is completed. So 30 to 33% of the syllabus is completed. Please go through those things and study properly. So another 1 week or 1.5 week, we'll be able to wind up this module 2. So study properly. Even all of you listen here. Saturday we have class, and you should attend the second hour class. Okay, this Saturday we have second hour class, so don't miss it. So I'll be continuing further. I'll be discussing very important concepts there. So make sure that you attend the classes on Saturday. So this Saturday we have, and further all the Saturdays we'll be having classes. Okay. Not only my subject, as per the timetable, it will be there. So all of you can attend that class. So we have been discussing on all these things. So if you have completed, shall I proceed further? Is that over? Is that completed, or you need some more time?
Wait.
Yeah, yeah. Okay. So after completing this, you just draw the next figure. That figure is on a variable attenuator. Now we have seen one figure in fixed attenuator. So the figure which I am going to show you further is on variable attenuator. So you can draw that figure in your notes, and I'll explain it how this variable attenuator works. So usually this explain attenuator with its figures and all, they may ask you a question. So they may ask you explain variable attenuator, or based on the question you can answer. It's always a one important question on attenuators, phase shifters, and all those things. So you can just refer some university question papers, which will give an idea that which type of questions are being repeated in the question paper again and again. And one thing I am making it clear for you, if you see the last 5 years question paper, I can say that 99% of the questions will be the same, and they are not going to come out with a different question paper for you as well. So except uh, some problems here and there, the theory will remain the same. So once you complete it, draw this figure. So draw this figure. So I will explain it. So what you can understand from here is this is a variable attenuator. So this is the section of the process where you can vary the thin resistive film. So this is the resistive film. Even you can see that the resistive film at the both the ends are tapered to each other, and the main requirement for tapering is that to avoid the reflections, and it should be more than half of the wavelength. So this resistive film, as and when you rotate from here, this resistive film will move in this direction. So it will move up in this direction. So when the resistive film moves up, you can see that as and when you keep on rotating it, you can see that the resistive film will move in this direction. So it will come up. So as and when the resistive film will come up, the flow of signal from this direction will be blocked. So that is what it is going to happen. And it depends on how much you are going to vary the resistive film. And so it is a variable attenuator. So if the resistive film is varied full extent, so it is going to completely block the entire signal. And if you are not varying it half of it, so other half you are going to pass the signal by reducing the strength of the signal. So that is what, so this is called as a variable attenuator. So you can draw this figure. So all of you complete that diagram, draw it properly. So you need to draw these diagrams even in answer papers, answer paper as well, if whether it is internal or external. If you are asked to explain the variable attenuator, draw this faster. So that's, you need to study these diagrams. So one more thing I want to just tell you, when you write the internals, be in time, and we'll be uh, doing everything in time. So don't get delayed. Then there are a lot of procedures for that. So you have to be clear with all the procedures, and make sure that you are in time before the examination. And I just wanted to try that link with you. If you have completed this, we'll just try that for just 5 minutes. You have completed this, writing all these things. You are still drawing it, Bhumika?
Yes.
Okay, another 2-3 minutes we'll wait. By the time I'll just post that link. So once you complete it, you can just rejoin there and check how the internal process looks like, and we'll take all of you should come in video mode, and just you can see that, we can see that.
Sir, completed, sir.
Okay, I have shared the link with you for internals. You can just go there and click on that and join. You can come out from here. Okay, as of now. Okay, then we'll wind up the class here. Thank you.